Okay. Well, let me welcome you to the very first Society for Financial Econometrics Seminar. I'm Andrew Patton, the organizer of this seminar series. And if you're like me, you're a bit sad that we're missing out on all those fun spring and summer conferences, traveling around, talking to people, hearing cool new research ideas. But since we're all now experts at virtual conferences and teleworking and Zoom hangouts, this is the exact right time to launch the SoFiE Seminar Series. This seminar series will be held every 2 weeks on Mondays at this time. And I very much hope that it will turn out to be a real addition to the research lives of financial econometricians around the world. I'm really excited about this initiative, and I hope that it lives up to what I think is its potential. So let's get started. Our first speaker is going to be Professor Viktor Todorov from Northwestern University, followed by a discussion from Professor Walter Distaso from Imperial College London. I will be collecting questions during the talk. So at the bottom of your Zoom screen, there are Q&A and chat buttons, and I'll be monitoring those throughout the talk. And then from time to time, Victor will pause to take questions, and I'll either read them out from the Q&A or the chat, or ask you to ask the question directly. So now, without any more time, let me turn it over to Victor. Victor, if you'd like to share your screen, and we can begin.
Yes. Thank you, Andrew, and thank you everybody for joining. Let me share my screen and let's get started. So we'll switch to full screen. No, yeah, so let's try again. Oops, there we go. Okay. So thank you very much. Thanks everybody for joining. So I'm going to talk today about, well, it's a long title, so I'll say just recalcitrant betas for short. And this is a joint work with Torben Andersen, my colleague here at Kellogg, and Martin Tusko, who is a postdoc here at Kellogg. So betas and market betas in this case, what we are talking about, is probably one of the most important subjects, objects of interest in finance, and kind of going back to the classical capital asset pricing model. In finance, betas show up in determine the amount of systematic risk which each stock should be rewarded, and that means that measuring the beta is very important for testing these asset pricing theories, not only for just kind of allocating and determining how much was the rate of return for individual stocks, but also testing more generally these asset pricing theories. The typical strategy goes in the following way. You first measure individually the betas using time series of data, and then you go in the cross-section and you test whether the cross-sectional variation in expected returns lines up with the individual estimates of betas. So estimating the beta correctly is crucial for our ability to test asset pricing theories. And conceptually measuring beta is a very simple thing. In fact, you just in a static world, so if you just kind of work with the capital asset pricing models, we assume everything is constant risk, the investment opportunity set stays constant. And so beta is a constant, then all we have to do is just run a linear regression of the individual stocks, so excess returns on the stock, on the market return in this case, if we're talking about the KPM, and the OLS will do it. Now, of course, betas are very difficult to measure, and because individual stocks also have a lot of idiosyncratic risk. And so if you want to have a very precise estimate of beta, which is crucial for the second stage when you're doing the cross-sectional regressions, where you try to line up the betas with the expected returns on the individual stocks, you want a very precise estimator of beta. And so if you are fixing the frequency at which you are estimating the betas, then the only way out of this is just go and look at the long horizon and say, In the earlier studies, we will look at something like 5 years of data with monthly returns, or even lower frequency. Now, what is really nice about then kind of the high frequency data, just like for measuring volatility, will provide a big boost in the efficiency in which we can measure the beta. And so formally, what you can see, if I go now and allow also the sampling frequency to change, not only the horizon, the time span of my data captured by T, but now I also allow for the sampling frequency, the times which I sample within the given interval to shrink, or to increase, the sampling intervals to decrease, then this in a static world, meaning when beta remains constant, is going to still provide an estimator of beta, but a more efficient estimator of beta. And the way you see this is simply by looking at the rate of convergence of the estimator is T over delta, where delta is now the length of the sampling interval. So you get for a given time span, you benefit from adding more and more, sampling more and more frequently within the interval. And so this, of course, is well known, and these high frequency financial econometrics have exploited successfully, I think, this fact that sampling more frequency means much better estimates of volatility, covariances, and hence betas. Now, however, one complication in which arises here is the fact that the betas vary over time. And so, I mean, this is an illustration of that fact with one standard stock like IBM, which has a beta close to 1, and so this is a rolling window estimate of beta, where the window size is 1 year, and you can see that even for such a big stock like IBM, you see a fair amount of variation of its market beta over a period of 7-8 years. And so if you go back to what I said earlier, that the traditional approach of measuring betas is using a rolling window of, say, 5 years, a lot of this variation will be missed. And now, if the asset pricing model is holding conditionally and not unconditionally, you probably want to capture some of that variation in your asset pricing tests. And so, how do we do that? I mean, if we stick to the low frequency, data, we need to help somehow. Help somehow with imposing some structure in order to capture some of the variation in the betas. And so a typical way will be, say, to assume that you have firm characteristics, so the betas depend on firm characteristics or on some macro variables, capturing some business cycle features and things like this. And that's going to help you, but of course is coming with an assumption on what drives the variation in betas. Now, in this world in which the betas vary over time, high frequency data has to help because it allows you to actually achieve a reasonable amount of precision with a much smaller windows of time when a lot of these variables which we think drive the variation in betas are going to be constant or close to being constant. And of course, the benefit will be that you can get away with fewer assumptions on the structure of this time variation in betas. However, the central premise for this, however, is that the market betas should be relatively constant or somewhat constant within short intervals of time. And so high frequency data, as I said, allows you to assume much less on the time variation. We don't need to assume that betas stay constant over 5-year windows. We can go to a much shorter window and benefit from this extra amount of data which we get. Now, So, but the central premise again is that locally the betas stay constant. And so what we did here, and this brings me now to what we do in this paper and justifies the name, the title we gave recalcitrant betas, is that if you look at the betas now estimated, so we picked here two stocks in the sample. One is high beta stock, which is Caterpillar, and the other one is a low beta stock, Johnson & Johnson. And we did the following experiment. We used high frequency intraday data to estimate the betas. If I remember right, the frequency was 5 minutes or 6 minutes, something like this. Relatively a frequency at which you wouldn't worry so much about microstructure noise, particularly in the more recent period, more recent data. We calculated the betas, market betas of these stocks, but we did the following. So we formed windows, local windows during the day, say an hour around market, after market open. And then we used returns, high frequency returns over that hour window for a year or for 2 weeks or something like this in a local window, and estimated the betas from those returns only. And then we repeated the same exercise for a different time of day. So for each time of the day, we had a local window which we used returns over a window of an hour around that point of the day. We estimated the betas by averaging across days, but only those returns over that time of the day. So what you see here is, in our opinion, is quite a striking pattern, and that's what made us puzzled about this, and we decided to write this paper, is that you see a very strong time variation in the beta. So and it's a time variation which is, first of all, is not small because we are talking about, so for Caterpillar at open being close to 1.35. And its beta gets down to a little bit more like 1.12. So that's a relatively big change in the beta of the stock. And this is happening over 1 day. And for Johnson & Johnson, in percentage terms, these gaps look even bigger. And not only this, but you also see that these patterns, these time of day patterns, which we will call them, are very pronounced. They are monotonic. This relationship in the case of Caterpillar, it's monotonically decreasing the beta. In the case of Johnson & Johnson, its beta is monotonically increasing. And so this was surprising to us when we first estimated it, because at least for me, for those of you who work in the area of high frequency financial econometrics, probably time of day patterns is something that you will be familiar with. And the time of day patterns, typically we talk about, we look at those associated with the volatility of the individual series. And just to illustrate this, if you look at the intraday market volatility periodicity, this is how it typically looks for a stock, for a market index, etc. It's very high. It's very high at volatility. Is very high at market open. Gets low towards noon, lunchtime, and then it gets high again towards market close. So that U-shape or diurnal pattern is not what we see with the betas. And if you are thinking that the diurnal pattern is similar for volatilities across assets and covariances between assets and the market, you'll probably think, and that was at least my prior coming into this, was that if you look at beta being a ratio of covariance over variance, this diurnal pattern will essentially cancel out, and you will see a beta which is constant during the day. The shape, however, of this variation is nothing like constant, and it doesn't look like a U shape, and it's more monotonically changing during the day. And so what we are going to say, in a nutshell, what we are going to do in this work here is try to document whether what we found here with these two particular stocks holds more generally in the cross-sectional of assets. So that's number one. Number two is, do we have a particular pattern in which this variation takes place? So if you look here, I mean, what is very nice, I think, is to tell you that something systematic is happening. Something is these functions are monotonic as a functions of time of day, but of course, in one case it's monotonically decreasing, and the other case it's monotonically increasing. And so you would think, what can be common among those two assets? And I will say the common thing here. And we will focus on kind of analyzing this later on more formally. But the common feature in this time of day variation in the betas of these two stocks is the fact that in both cases, the beta compresses towards one. And so in the high beta stock, that means that the beta will decline during the day. In the case of the low beta stock, it means that its beta will increase during the day. And so that's the common feature between the time variation of betas in these two stocks. And so this is something that we are going to develop the tools to actually formally test whether this is the case. Now, if this variation is indeed there, then the natural question, next question you might ask, and this is something which we will study here, is should we care about that time variation? And is it associated with, in other words, is that time variation associated with asset pricing varying or in the cross section in a particular way? We'll provide evidence in favor of that question, and finally, and which I think is probably from an economic point of view the most important thing, is what can rationalize economically this pattern, this behavior in betas. Certainly, if we think of variation in betas, which is associated with characteristics, firm characteristics, or even macro variables, you don't think of those variables changing intraday. And so that is really, from that point of view, this is really puzzling actually to see this behavior. And this was certainly my prior. It's too much variation in the betas in a way. But now that it's there, it opens the question, what do we do with, and how do we actually aggregate the high frequency data into saying something meaningful for asset pricing? Okay, so I'll get started. Maybe, I don't know whether that's the right time to have a few questions, to take a few questions, Andrew, or?
Yes, yeah, we've got a couple of questions that have come through. Since there've only been a couple, maybe I'll unmute the people and get them to ask them themselves. So the first question.
Yeah, why not we do that this way? Yeah.
Sound good? I'll see if that works. Sophia, would you like to ask your question?
Yeah,
Yes.
of course. So Victor, in this paper, you care about the intraday variation of betas. However, betas for each interval is still computed using high frequency returns over 252 window. So essentially, you're assuming there's no day-to-day variation.
Okay, that's a good point. Okay, so very good point, very good question. Thank you, Sophia. And so now that's not actually, we don't assume that. So we don't assume that, but what we have done is we have aggregated this across day variation in the betas, and this is with the effort to let the intraday variation become clearer. Now, what we will see later, well, depending on time actually, but I hope I can show you later on, is that this intraday, this gap between dispersion of betas at open and close actually fluctuates quite a bit over time, in a way which lineups with what we think is the economic rationale for some of this, at least some of this variation in betas. But you are right, you have to make a compromise somewhere. And so what I did, in a way, what we did is we integrated this across day variation in betas so that we can see only the time series variation, the intraday variation in the betas. And there's another one? Or?
Yes, there was another question from Neil. I'll unmute Neil, and Neil, if you'd like to ask your question. Well, did I? There we go, good.
So a lot of trading goes on outside the time period of your graph right at the beginning of the open and right at the end of the close. Very high percentage of trading. And so I wonder how the betas during those periods relate to the betas in your graph.
So do you have in mind, say the 8:30 to 8:35 or something like this?
Yeah, or just before 4 o'clock when the market closes.
Oh, okay, yeah. So, yeah, well, for those, I don't have much to, unfortunately, I don't have anything to say about this because, but we should probably certainly look into that. The only problem here is that for individual stocks, it's a little bit hard to find data. And I think, but you are right that on the market index, at least on the stock market index, there's a lot of trading happening. Now, I'm not aware for the individual stocks whether this is the case and whether to what extent we can actually say something about them. But in any case, what we are doing here is we are integrating over a window of 2 hours or an hour or something like that. It's just very difficult to get the precision of estimating beta over such super short windows of time. Yeah. But this is something, I mean, yeah, we should probably, I will leave it at that because I don't know the answer, but we will have to look at this. Yeah.
Okay, Victor, we'll let you move forward. I'll just use this moment to tell you we're about halfway. You have 20 minutes left. Oh,
20 minutes left. Okay, so yeah, and I'm still in my introductory slides. Okay, I better speed up. Okay, so, well, in a way, describing the theory, I think, will be relatively simple. Measuring betas, again. So we have assets which evolve continuously in time. And we are interested in the beta, which is the sensitivity with respect to the market return, which is indexed with 0. And what we do is, when measuring the betas, we will of course allow for additional factors to be driving market returns, but we will orthogonalize them with respect to the market, and then we will have a lot of we will have also idiosyncratic risk. Okay, so we will do the measurement. We will do the measurement of betas within local windows of time using the high frequency returns. And what we were going to estimate here, and in the paper we can characterize the whole cross-sectional distribution of beta. So that's but we will focus on one statistic, one measure of the cross-sectional distribution of the betas, which I think displays most clearly what's happening with those betas and how they vary during the day. And this is cross-sectional dispersion in market betas, or simply said, that's just the cross-sectional variance of betas. But now note that the index of betas here we have T and kappa, and so T will stay for the trading days, and kappa will denote the time of day, when we are measuring the betas. And so what we will recognize, as SoFiE pointed out here, that there's a variation in time and there's a variation in kappa as well. And so what we will be interested primarily here is just capture that variation in kappa, but later on we will come back to the question of the variation in terms of time. Okay, and so how do we proceed from here? And since I don't have that much time, I will just quickly sketch the idea, and the details are in the paper. So we will proceed by measuring locally the beta over a short window of time, where you are thinking of beta being approximately constant. Okay, and those windows, of course, asymptotically, in an asymptotic sense, they have to be shrinking down to 0 at a certain rate, which optimizes bias variance trade-offs in measuring the betas. And so in those local windows, however, things are very nice and easy, and sort of go back to they go back to traditional OLS regressions, which we're used to when we estimate betas. And so what you have is you have a market portfolio which has a return. If you throw out the jumps, this is just normally distributed returns, and then you have your beta times the market return plus an error term. Now that error term has a little bit a bit complicated structure in a way, because it's not just idiosyncratic risk, but you have also other systematic factors. And what this will mean is that if we're looking at an asymptotic setup in which the cross-sectional dimension of the panel also increases, asymptotically increases, then no matter how much you average over those systematic risk factors, their order of magnitude is not going to shrink. And that means that they are going to drive the asymptotic distribution in this case. Now, if you have, of course, if you assume that there are no other factors than the market, then it's only the idiosyncratic risk which will drive the distribution, and the rate of convergence in this case will be very simple. But in any case, we have an asymptotic setup in which both the number of observations increases, those I's increases within a local window of the time of the day where we're trying to measure the beta, and you also have potentially the number of stocks in the cross section increasing. And so we designed the theory, but the betas, how you measure betas is standard, covariance over variance. And what we are interested in, just to remind you, is actually the dispersion, so centered, the beta centered at 1. And so we are going to subtract 1 from these calculations. And that's the sample counterpart of the dispersion measure. As a result, becomes this measure of covariance over variance, and then you square it, and that's your dispersion. Right. So I don't have much time to go through the details of how the asymptotics which drive to describe the dispersion measure. The only thing I will say is that there are tricky questions here on how to make the inference in a way which doesn't depend, or you don't need to make a statement on how many other factors are driving returns and things like this. Is a very nice, I think, technique which we introduced here to deal with that problem. But in some sense, this will go into details. I just don't have much time to talk about this now. Once you do this, bias correct your statistic and measure the asymptotic variance, we will end up with normally distributed random variables. Once we use the theory and analyze and calculate those betas, here's what you get. One way to look at this. These are cross-sectional quantiles of betas as a function of time of day. And here we use the whole data set, which is around 8 years or 9 years of data to do those calculations. And what you see is the 5th, 25th, 50th, 75th, and 95th quantiles of the cross-sectional quantiles of betas. What you see is that the median is approximately 1, and there's no variation in the betas. There's no variation in the betas of the betas of these stocks in these portfolios here. But once you move away from 1, you see that the high beta stocks tend to have betas which are going down, and the low beta stocks tend to have betas which are going up. In both cases, the dispersion in cross-sectional dispersion of betas starts shrinking. And now to see, so if we calculate from this estimated betas, if we calculate their cross-sectional second moment, what you will see in this plot, in other words, the dispersion, a very strong and pronounced pattern, and basically the dispersion decreases more than 50% by the end of the trading day. And this is a very strong decrease. It's just, it's hard to explain this with any type of noise and things like this. These effects are, in my opinion, are way too big to be rationalized with this. Okay, now what we did so far, we looked at the betas, the cross-sectional distribution of betas, but at a given point in the day. But as Sophia pointed out, it is certainly interesting to look at what happens with the betas, or what happens with these cross-sectional distributions. How do they move? How do they move over time? But now, once we realize that the beta itself is changing during the day, then what we are having here really is functions of the time of day. And we are interested in the movements of those functions of time of day. Here, we're looking at the dispersion of cross-sectional dispersion of beta as a function of time of day, but you can think of anything which characterizes the cross-sectional distribution of beta. Think of it as a function of time of day and how that moves over time. That's where we are heading now. Now, to do this analysis, however, you do need functional limit theory, which will characterize the behavior of these functions or the behavior of our estimates of these quantities, these functions in the day. Now, this is a bit more complicated because if you look period locally, the estimates of beta, they're independent normals, and actually it's hard to characterize their uniform behavior. But luckily, what you can do is you can characterize these functions, you can map into their Fourier transforms, and you can look at their and look for uniform convergence in that space, which is actually going to work successfully in this case. But what it boils down to intuitively is this function, which TD stands for total dispersion. What you do is you look at the dispersion, cross-sectional dispersion of beta at different times of the day, and you weight it. You just put weights over the dispersions at open and lunch, etc. And then that gives you a family of functions which depends on the weight you assign to each part of the day, informing your total dispersion. And by varying the weight, you can check the behavior of the dispersion function during different parts of the day. So for this type of functions, it's relatively easy to derive the convergence result. It's a uniform law on this space of functions indexed by the argument here U. Again, I don't have enough time to talk about this, so I'll just say that if you do this analysis, now it's difficult for me to display functions changing over time. So what I will do, I will use the fact that what we found is that these dispersion functions, they look monotonic. They're not always monotonic, but probably, so that's in any ways, it's a first approximation, probably. That's not such a bad thing. And so what we will focus on, what we do in this plot, we just display the cross-sectional dispersion of beta at open and close, and how it evolves over time. Here we use the window of 1 year in calculating this. And this, I think, this 1 year window gives us a relatively good precision. But what you can see is that this quantity or this gap between the dispersion at open and close is far from being constant and actually varies a lot. In end of 2015, it shrank a lot, and then it increased a lot, and then again it's going down. I will, and so we can quantify and we can do the formal test and we can things like this. So for sure, there's a lot of dispersion. There's a lot of time series variation in this function of dispersion of beta, intraday dispersion of beta. Now, okay, so maybe I can take one quick question, but I'm really probably, 6 minutes left. So Andrew, is there a question?
I think, yeah, given the time constraint, maybe there are a couple of questions, but maybe I'll wait for those for the Q&A at the end of the.
Okay, yeah, let's do that, because I think that now I have 6 minutes?
Yes.
Yep. Okay. All right. So now we will go to trying to rationalize and asset pricing implications of this. So I will go very quickly through the asset pricing implications, because I think it's a little bit, I think it's more important to understand the economic sources behind this and then think about what asset pricing implications this result has. But anyways, so that's the fact that we see, can we line up, the way I would pose this question here is, can we line up this time series variation in betas intraday with returns on with the expected returns of stocks? And so what we are going to do is we are going to sort the betas into sort stocks into according to their betas from low to high, and we are going to form a portfolio at market open, which is zero beta, and it will gradually become positive beta. Positive beta. That is, it will become positive beta just because you have time series variation, intraday variation in the beta. Now, how you do that? The way we did it is we go we buy low beta stocks and then we short high beta stocks, but we adjust the betas. We adjust the two portfolios in a way that their beta at market open is zero. We did something similar with close. I don't have time to talk much about this because we really want to talk about the economic rationale for what's happening here. But you will see that there is statistically significant returns of doing this. So in the remaining 4 minutes or so, let me just talk a little bit of what is really happening. And in a way, I personally don't like the idea of the betas varying so much during the day, because you are thinking of betas capturing fundamental risk, which is certainly not changing during the day. And so how can we think about what is happening here? Here's our thinking. And so suppose that the market portfolio consists of, so I casted this in discrete time just to make probably the analysis of the point easier. But so suppose we're looking in discrete time market portfolio, and it has two types of shocks. And these are fundamental shocks, systematic shocks like, for example, if you're thinking of the decomposition of John Campbell, this will be, you can think of epsilon 1 being cash flow news and epsilon 2 being discount rate shocks. Now, they don't necessarily need to be orthogonal to each other, but in this exercise, we will do this orthogonalization, and or you can kind of separate them into two orthogonal shocks. And of course, similar types of decompositions you will also find naturally they come from equilibrium asset pricing models. Now, and so what I think then in this case is, so there are two types of shocks. Cash flow, let's label them cash flow and discount rate shocks. And then I'm thinking of the beta exposure of assets to these types of shocks being different, but being constant, or at least constant during the day. So this is beta 1 and beta 2. They deliberately, as you can see, they don't have a subscript T, just to highlight the fact that they are assumed to be constant. But now, suppose that the intensity of news, different types of news, the epsilon 1, epsilon 2, is actually varying. And that's not so implausible. In fact, the intensity, how much cash flow news or how much discount rate type shocks you have in a given point in time can change actually very easily. And in this case, it's very easy to say the market beta, what the market beta is doing is just a weighted average of the two betas, which is cash flow beta and discount rate beta. And even though those two quantities are different, then what we are seeing here is we are seeing variation in the beta just because the intensity of news, different types of news driving the market portfolio is moving around. Now, for this to be the case, and to be a plausible explanation of what we see here, we need two things. First, we need those two betas to be different, right? I mean, because if they are the same, obviously you will sum up the two things, you will end up with a constant beta. But, and secondly, we need also this news arrivals to have varying intensity. So how can we test this hypothesis? So what we did here, we looked at two external sources of validation, and I will wrap up in a minute. So the first thing is we went into Ravenpack and collected all news related to firms, so cash flow news, and we weighted them according to the weight in the market portfolio of the individual stocks, this news. And what you see is this very pronounced and very clear pattern where the amount of news you have at market open, cash flow news, is much higher than what you see at market close. By the way, this open betas calculated at market open, they are very similar in a way with the overnight, if you do overnight beta estimation. And then, and that's in that sense, this is actually consistent with this evidence here. You have a lot of cash flow news overnight, but they tend to be more clustered at market open. Now, the second piece of evidence, well, discount rate shocks, they are much more, and they're much harder to see. But we did the following thing. In some of my earlier work with Tim Bollerslev and Torben Andersen, so we computed these option implied measures of risk aversion, or something that resides in the left tail, the extreme left tail, and we shown there that a lot of it is not so much to do with the risk, the amount of risk, but a lot of risk aversion moving around. And so that's that is in a way getting into these discount rate shocks. And so what we decided to do here is we sorted, or we looked at days when there was a big change in that tail index, which is just telling you that there's a big shock, presumably to discount rate shock, okay? And so the two lines which you see here is the dispersions which are computed, at the days. The solid line is when there's a big discount rate shock. And the other line is the average on the typical day. As you can see, what happens when there's a big discount rate shock, there's a compression, overall compression of the betas, and that's consistent with this idea that there is a discount rate beta which is much more compressed towards 1, and there is a cash flow beta which is more dispersed. And depending on which shocks dominate in the market portfolio, you can see this variation. I think I should stop here. That's exactly 40 minutes. And I will not conclude because there's a lot more to be done to conclude actually this topic, but I'm happy to take questions. Yeah.
Okay, well, thanks very much, Victor. Thanks for being on time. I will go straight to the discussant, and then we'll come back and we'll take questions from the audience after his discussion. So Walter, if you would like to share your screen and unmute.
Can you see?
Yes.
Excellent. I think. Okay. Well, good. Thank you very much, Andrew, for the invitation. I won't kind of go into a traditional discussion, which essentially starts with the summary of what the paper is about, because this would take up too much of my time. I will go straight to the points if I can. There's a problem with my mouse. Yeah. Okay, so I think some of the points have been already kind of answered by Victor, but essentially what I wanted to say is that you can allow for a more general setup than what you have, for most kind of systematic observed factors, with the proviso that you just have to basically orthogonalize them with respect to the market. Now data are available, whether it is ETFs or there's this paper by Yassin, Ilse, and Asheng, which essentially contains some kind of data. The point probably which has more substance is about the cross-sectional dimension, which essentially in practice it is time varying, because you know, in a general sense, stocks can be kind of taken out from the market. New stocks can come in the market. Here we're talking about an index, so it's slightly different, but essentially it is time varying. Now you take care of that in the empirical application, because what you do, you essentially choose the stocks which have been constituents of the index for the whole time. In fact, you know, from 500 you go down to, I think, slightly less than 393 stocks. But the point is that essentially, you know, what implicitly you're doing, you're saying that the process of entry and exit is exogenous. Okay, now, I mean, I'm not questioning that, but perhaps you should be more kind of explicit about that, because the moment it's exogenous, you can condition on that, and then, you know, it's done. It's another matter whether this is empirically justified, you know, inclusion in an index which captures large stocks probably has some kind of endogeneity, but of course, you know, this becomes too complicated, but I think it's still important to kind of highlight the point. Now, going to your kind of cross-sectional statistic, you have this nice kind of trimming device to avoid the ratio to blow up when, you know, when V is low. This is kind of standard. What I just wanted to kind of ask, how do you get this rate of log essentially? Because Andrews has done some kind of you know, some kind of work on optimal trimming kind of sequence for non-parametric estimators. I don't know whether you have taken that into account explicitly. And the other thing that I wanted to highlight is, perhaps I've missed it, but essentially you need an assumption for a sufficient degree of sparsities of the bases. Otherwise, you know, computation of a density becomes kind of quite tricky. You need the betas to be sufficiently sparse so that you can compute a cross-sectional distribution. And then, of course, you know, you probably saw it coming, but would things become incredibly complicated if you allowed for noise? I mean, I think you kind of have a 3 minutes sampling frequency, which is probably on the border of being okay, but I think, I mean, it's kind of a comment that I'm sure a lot of people will ask you in future kind of discussions. Now, going to the empirical results, so you have this kind of nice rationalization of your results with the different kind of uneven flow of information arrival throughout the day. You show that this is actually true empirically. And I just wanted to ask, is the DGP that you have in equation 3 consistent with this? Because essentially, you would have, if that's, you know, you would have the betas to be a function or a variable that essentially captures the arrival of information throughout the day. I think you can do it, but probably, you know, because you are explaining an empirical kind of fact with this kind of information of flow of information arrival throughout the day, you should make sure that the model is kind of consistent with the explanation. And the other thing is, okay, it's a very nice explanation. Have you thought about alternative ones, which are based on kind of liquidity on the kind of different traders trading high beta stocks and low beta stocks? I don't know if there is a lot of cross-sectional kind of difference in the volume and liquidity of these stocks throughout the day, but probably something that you know, you could look at. And the other thing is, there's a growing literature about intraday patterns of returns, and I think your paper essentially adds quite a lot to it through the different kind of insight. And I think it has also the potential of explaining some of their results, because in many cases, essentially, the explanation has not been there or has been kind of ad hoc in some sense. So I think, you know, adding a risk dimension, which is essentially what you do, could probably help in explaining some of these findings. Okay, so I think I am on time, Andrew.
Yes, you are, Walter. You've got another minute or two if you'd like to use it.
I basically skipped the introduction just to get to the points and to make sure that essentially I basically didn't go over time. So I'm okay with it. But thank you very much again.
Thank you, Walter. Victor, would you like to briefly respond? And then we've got a few questions coming in from the audience.
Yeah. So I think it's better probably I don't share the screen. I just talk.
Why don't we go back to just the?
Or should I go to share screen or no?
Only if you need to.
No, okay. So I'll just talk. First of all, thank you, Walter. A lot of questions, and so and so there's a lot of questions on the econometrics and a lot of questions on the empirical side, and certainly a lot of things to do, I think. I will just talk about a few things. I'll briefly mention two of the many comments which you provided, and this is recorded so I can see the slides, your slides later on in more details. You're absolutely right about these exits and the entries and all that, all these questions. We were very conservative with our sample, which means that we were looking S&P 500 or 350 stocks or something like this, mainly because of microstructure and noise-related issues. Now we're in the process of extending the sample to, we in fact extended it to 500, and it's kind of more ambitious, where I think that this question will become more pertinent. Now regarding there's nothing wrong with the empirical, there's nothing wrong with the beta varying over time, and meaning with the information arrival being associated with some cash flow news, etc. If you think that they are kind of the type of Cadillac sort of dynamics, then things will go through. Now, finally, about this the economic question, I think we are still trying to understand. So we did a lot of follow-up work after this and you actually get stronger and stronger results if you use shorter windows to estimate this pattern, because there's a lot of time series variation in it. And I can talk maybe of some of those questions, maybe during the questions Q&A session, this will become clear, so I can kind of provide more details on this. But thanks for great comments.
Okay, well, let me, we've got a few questions here. One that came in during the talk that I had delayed till the end was from Gustavo. So let me unmute him and he can ask his question.
Okay. Yes.
All right. Hi, Victor.
Hi, Gustavo.
Great talk. I was kind of thinking about the questions of what could potentially be driving this. And the first thought I had was kind of what Walter was saying, that maybe there's kind of market segmentation, that some stocks are being traded by only a certain group of investors versus others by others. So I was wondering whether you had looked at kind of like the investor bases of the different stocks and how that's related to kind of discrepancies in these betas across stocks. And then the other question that I thought was whether you've looked at kind of announcement versus non-announcement days, because there's all this talk about how all the risk premium are earned on announcement days. So maybe there's something there that that's driving that.
Okay, thank you, Gustavo. Let me share the screen actually. Now I think I will share the screen then. So now that you asked the question about, I will start with the last question about the announcements. Yes, we did. That's a very great, that's a great point. And if you think, say, we looked at FOMC announcement because it happens during the day. And this is most likely to generate a discount rate type shock. And so if this is the case, and if we think that these are more stable, what we should see is the extra volatility which is generated on the market because of this FOMC shock. The beta of the stocks with respect to that extra volatility should not have this time of day pattern. And here's what you get. And so let me show you. Here's what you get. If you look at just the FOMC, or the days after the days on the FOMC, and you compare the extra volatility, just look at the extra volatility which is generated from this FOMC shock, what you see is the time of day pattern is gone. So we tamed the betas, right? I mean, you remove that this big time of day effect. And so which reinforces, in my opinion, more the idea that this is really what's happening here is that it's different types of news shocks driving the market portfolio, and the stocks react differently to those types of shocks. We did a very similar thing, but then only using periods around earning announcements. And so we just looked at the extra volatility. The earning announcements are clustered. So most of stocks are announced within a week or two period. And we looked at the extra volatility which is generated on the market because of that. And we estimated the betas, and look what we got. We got, again, constant time of day betas. There's no more time variation. And interestingly, that dispersion which you get here of the beta is very high. And the dispersion which you get here after the FOMC is very, very low, which is consistent with that conjecture that what's driving probably this is more dispersed cash flow betas than discount rate betas, but seemingly they are different. Yeah. Okay, so I'll kind of let me stop so that we don't have much time.
We have a couple more questions. Maybe we can squeeze them in the last 5 minutes. Numadai has raised his hand, so I'll unmute him and get him to ask his question directly.
Yeah, thank you. I have two few questions. One is, I understand your story, but I am not sure that you explained with your story the monotonicity. And is it really, do you have the unpredicted monotonicity for all the assets? That's the first question. And second is, at the end of the day, what would be the best measure of the market beta? Should we back to lower frequencies like daily data? Thank you.
Okay, thank you, Noor. It's nice to hear friends from all over the world. This was kind of that's really awesome. So, okay, the second. Let me start with the second question. That's exactly. I mean, so what should we do now that we understand this huge time series variation? I mean, one thing which I forgot, which Walter pointed out, and this is very, it's a very good point. Yes, here I estimate the market betas, but I orthogonalized all other risk factors and projected them on the market, and so and disregarded their variation. Now, if you think that here, what is really happening is what the story we are telling here, that there are different types of shocks and different sensitivity of stocks. Well, one way to deal with this problem then is to introduce other observable factors which can control for at least one of these types of shocks. And so this is, for example, the approach taken by Campbell and Quarters, where they try to proxy discount rate shocks by projecting on yields and all sorts of variables which are driving the conditional information set. I think that this is this comes with a lot of assumptions, and I think it's potentially dangerous. And I'm more in favor of sort of doing the thing which we are. I mean, I would say I will not make a concrete suggestion now whether we should go to low. I still think that high frequency beta is very useful, but we just have to be careful what it is actually measuring, and is there different cross-sectional ranking of stocks according to the different betas, right? I mean, that's also one thing which needs to be investigated, studied before we make the conclusion whether we should just integrate the beta during the day, or we should care about the fact that in some days, and we know when some days we will have more cash flow news and in others we have less, we should account for those differences. I think that this is something, it's too big of a question for me to answer in that. I just don't know the answer quite yet. Yeah.
Okay, great. Well, we have one last question. I think we can just squeeze it in. Dobry, I'll get you to ask your question. So let me, you can hear another familiar
Yes.
Yeah, hello. Does everyone hear me?
Yes.
It's a very nice talk, Victor. You got me thinking actually very much in the spirit of what Noor was asking, his second question. So wouldn't it be useful to compare the intraday betas at the open versus the close to the betas computed from close to close returns over a very long run sample? And wouldn't this actually kind of let us understand, are we kind of at the open converging or diverging from what would be deemed to be sort of the correct betas, assuming that noise cancels out?
No, that's absolutely right. And so if you do open to open or close to close, right, betas, and you use this comparison, what you will get is something like an average of the open and the closed betas, and so it will become into the middle. But I think what is important to note that the market risks are much more complicated, and just getting one overall measure, I don't think it's quite right. I mean, we should control for the different types of risks. They probably earn different risk premia. And in fact, I mean, this is the line, this is the good beta, bad beta story, right? I mean, I don't know whether it's quite only the good beta, bad beta story here. You probably have other sources of risk which you should worry about, and all these issues of clientele effects and things like this and how they actually can impact behavior. I mean, I think it is important before we kind of use high frequency betas in our analysis, or I mean, or try to understand them. Yeah.
Okay, well, we're right on 12 midday in East
Yeah.
Coast time anyway. It's different times all around the world, but we're right on midday. So Victor, if you wouldn't mind stopping to share your screen.
Yes. So yes, I forgot about that.
Awesome, great. Well, let me thank Victor and Walter, our speaker and discussant for today, for joining this experiment in virtual financial econometrics research. And let me also take this opportunity to switch my background and advertise the next SoFiE seminar. It's coming in 2 weeks. We're going to have Svetlana Brizgalova from LBS, London Business School, as the presenter, and her discussant will be Raymond Kahn from Toronto. So thank you all for joining in. I hope you found it an interesting day, and I apologize that I wasn't able to get to everyone's questions. We'll learn how this goes as we proceed through.
Thank you, Andrew. Thank you.
Thanks everybody for coming.
Thank you very much.